Hey everyone, I'm Jacob. I'm a machine learning engineer and developer evangelist at Voxel 51. For those of you who don't know, 51 is the leading open source toolkit for curation and visualization of visual datasets. And 51 plugins are an extensible framework that allow you to customize 51 for your workflows. Right now, we're in the middle of a 10 weeks of plugin series where every week we bring you one or multiple plugins that show new workflows that are enabled with 51 plugins. And today we're going to be talking about the week 9 plugin, which is concept space traversal. Now, what do we mean by concept space traversal? We'll get into that shortly. So right now we are in the 51 app and we're looking at the test split of the Cocoa 2017 dataset. And I've pre-computed some embeddings with CLIP, the contrastive language image pre-training model from OpenAI. And this model embeds both images and text in the same space so that you can, in some ways, work with both of them at the same time. So you can search for images via text. So why don't we do that just to show you what it looks like? We can search for like a cow, just because I know there's a cow right here. And we can see a bunch of cows show up. But today we're going to be doing a little bit more than that, not just searching for images via natural language, but combining images and natural language all in one to move throughout the space of concepts by traversing the space of embeddings. So let's reset this and let's click on this button over here, which says Open Traversal Panel. So this is concept traversal, and by that I mean we're going to move through the space of embeddings using these embeddings and the text prompts that generate those embeddings as our stand-ins for concepts or for notions in this abstract space. And the first thing we want to do is we want to set an initial image. So let's go through our list of images and say, let's find one that we like to start out with. Let's do this one. So we select it, we hit this checkbox over here, and then we can press this Set Initial Image button. And now we see a preview of this image in the panel. We can choose which index we want to use. So if there are multiple vector indexes on our data, we can choose which one, and this could be for a variety of reasons, including maybe we have multiple different models or different vector backends or different hyperparameters for the vector database that we want to try out. So we can choose which one we want. In this case, I only have one here, but you could have multiple. And then we have these input boxes for concepts. And this is where we're going to add text into the mix. So let's say I wanted to add the text concept healthy, and I'm going to add some amount of that concept. And I'm going to add this is the full multiplicative factor. So for now, both these two sliders right here don't seem to be doing anything different, but they will in a second when we add in more concepts. So just bear with me for a moment while we have two sliders that are active. Now we can hit traverse, and what we've done is we have moved through the space of concepts or embeddings by adding some amount of the embedding vector for the text prompt healthy to the initial embedding vector for this image. And we can choose to go more in that direction. Let's say we actually want to add more. And as we update, it's going to continually update and re-query our vector index. So here we added more healthy. We can even add some more. And so it's getting healthier and healthier, and we're losing some of the initial image. Now, if instead I turn this all the way down, let's go down even further. So when we go down far enough on the scale, and this is an arbitrary scale that just multiplies the text embedding vector that is added to the image embedding vector before we normalize the vector and do the query in embedding space. When we make this small enough, then the image's embedding is what matters. And so we see we get a bunch of pizza over here, just like the original image. And this is the same things we would have if we were just to do a similarity search on this image. But things start to get interesting when we add in other concepts. So let's put this back up to something somewhat higher. And now we can add in another concept, like let's say we wanted to add in colorful. And let's add it like this. So what's going on here is now we're adding two concepts to the initial image. So we have the concept healthy and the concept colorful, and these are the relative weights that we are assigning to these concepts. And then this is the absolute value of the multiplier that we are applying to the entire uh, text concept entity at the end before we add that to the image embedding and do normalization. That's why we have two sliders here. We have these relative sliders and we have this absolute slider. Now we can deprioritize the healthy and uh, you know give more priority to colorful, and we can see it updates. And now we got this really colorful image of a bunch of apples. We can go even further, and if we actually went all the way up, let's see, we might not even have food anymore if we went all the way up on this and all the way down over here. So we do that, then we actually get some non-food entities over here. So this is a great way to explore the space of your images. So by adding concepts together in arbitrary amounts and dynamically interacting with your data in this way, you can kind of explore and see what the space of concepts looks like, how densely it is populated in certain areas and how sparsely it's populated in other areas. You can see what the model thinks is close to what else. You can really be incredibly multimodal and look through text and images at the same time. So how does this work? Let's go on over to the Concept Space Traversal plugin GitHub repo. And if you want to use this plugin yourself, you can go over to this GitHub repo and add it. So you can use this FiftyOne plugins command line interface syntax over here, where you do FiftyOne plugins download and then pass in the name of the GitHub repo. So Jacob Marks, that's me, /Concept Space Traversal plugin. And once you do that, you will have a panel that can then be opened up. So you will see this panel, but you actually won't be able to use this panel until you have a similarity index on your dataset. And you can compute that similarity index like this. So this is the code that would allow you to do it. You can use whatever vector backend you'd like. You can use Quadrant, Pinecone, Milvus, or LaMCB. We have support for all of them. Or if you don't use any of those, if you just use the default, it will create a nearest neighbors graph using sklearn. Let's hop on over to our init.py file, which has our Python logic to see what's going on under the hood. So this plugin assumes that you've already generated the similarity index on your data, and it looks through all the indexes on your dataset and finds any of them that have support for prompts. So that means that they're multimodal. They support both text and images, which is necessary for traversing this space in the way that we have done, and also requires that they have a cosine metric. Now, this cosine metric is key here because that means that it is looking at the angle between vectors in this space and not necessarily just the Euclidean distance between them. This generate destination vector function over here takes our index and it takes our sample. So this is the sample that we've selected as our initial launching off point. So this is the sample that we selected and it appears right here. It finds the embedding for this, and then it generates concept embeddings for all of the concepts that we have defined in these blocks over here. And then it adds them together with some scaling and normalization. And run traversal just basically does a sort by similarity on this destination vector. Here we have our open traversal panel. If you've seen some of the other plugins, this is par for the course, a plugin that, an operator that basically just when you call it, when you click a button, it will open this panel. And you can also do this via the operators list that we saw earlier. And then we have the run traversal operator. And this operator is going to encode the logic for sample ID, the brain key, the text scale, and all of our concepts. These are the text concepts and their relative scales. It runs the traversal, then it serializes the view to make it able to be passed into JavaScript, and then it sets the view. And finally, we have a get sample URL operator. Now, what is this doing? So here we're passing in our sample ID, and we are returning a URL, this unique resource URL for the media file, the photo that is associated with the sample that we've selected. And this is actually necessary so that we can have this image preview show up in our panel. That's what makes this happen over here. So those are our three operators. And this operator and a lot of the JavaScript that you're about to see is in large part thanks to Ibrahim, one of our engineers at Voxel 51, who was integral in making this plugin happen. This plugin was a collaborative work with myself and Ibrahim. So if we go to the source and we look at the Traversal plugin TypeScript file, we can see the JavaScript that is necessary for implementing the UI logic that we were just looking at in the panel. So this right here is what is implementing the markers, the tick lines on our sliders. We've got a button here. We've got these custom sliders. So this defines the properties of the sliders, the format, or the style. We've got this default function that we're exporting, Traversal panel, and this has a bunch of things in it. So we've got our brain runs. This is finding the valid brain runs, what our current brain run is, so which similarity index we actually want to use here. We have our selected samples, and we can set our starting point for our traversal with whatever the final selected sample that we have is. We have our concept sliders, and we can have arbitrarily many of these. This is handling changes that occur to different things that we just defined. We can set the concept sliders, we can set them the text values, and then the relative strengths for each of those concepts. And here we've got our validation. And this is a lot of Ibrahim's code, which was absolutely essential. And I am not a JavaScript developer, so I am in tremendous debt to Ibrahim for making this happen. And here we have the main UI of the panel itself. So we've got the concept traversal text, we have the text that went under that, we have the image preview, the starting point, the valid brain runs, our concept sliders, and then we have the absolute scale. And at the very end, we have an operator execution. So this operator executor, if we go up to the top here, we should see where is the operator executor happening. So right over here, we've actually got two operator executors. So one of them is this traverser, and this is actually what's going to be doing the traversal or the search, basically generating the new vectors, the destination vectors as we're calling them, and then doing a similarity search on our vector index with that. And this one right here, this operator executor, this get sample URL, is getting the unique URL for the image that we are setting as the preview, as we mentioned before. And that's really all there is to it. So this is a great way to explore your data, to see kind of what the internal structure is. So I would use this in conjunction with your traditional similarity searches, natural language searches, visualization of the embeddings in dimension reduction techniques, so UMAP, TSNE, PCA. This is just another way to understand and explore your data. If you liked this, you should check out our concept interpolation plugin, our reverse image search plugin, and our audio or cross-modal retrieval plugin, which uses ImageBind, allows you to search via audio files for images that match that audio. Thanks so much, and see you next time.